have learned moving average and autoregressive random processes, and we had one example for each. For instance, line spectra random processes or AR processes. How many components they have determines the order of autoregressive. So if you have a random process which has a power spectral density, which has energy here, depending on how many frequencies you have, this is an AR process. For instance, this one is AR of 3, and then we have also had a moving average random process as example. So in this video, we'll work on autoregressive moving average random processes. So in autoregressive moving average random process, x of n is generated by two components. So x of n is equal to two terms, a moving average component plus an autoregressive. So the autoregressive is a linear combination of previous samples of x of n, and the moving average is a linear combination of some successive samples of the input random process, which is white. So ARMA process, or autoregressive moving average process, with a degree of n and m, we call a random process ARMA n and m if it could be expressed as follows, which means that x of n is equal to a moving average part of degree m. How many parameters we have? We have m plus 1 parameter, and then plus this one. So if I put this one here and say, okay, minus this part, then x of n can be generated like that. And similarly, if you want to calculate I of n, you can put the other side. So the inverse of this filter you can calculate. So assuming that I of n is a white sensitization random process, but also I of n is white, and also mean of I of n to the power of 2 is equal to 1, because here I have n parameters here, and then here I have m plus 1. So the total number of parameters is m plus n plus 1. So this is a general ARMA process. So if the degree of m is very large, it is going to become very difficult to solve Yule-Walker equation. It's not much application. Usually n is a small in practical situation, but this n can be increased because usually for even large n, for arbitrary n, the set of equation becomes linear if particularly n is equal to 1. So in general case, the set of Yule-Walker equation becomes nonlinear. So ARMA is usually avoided unless if this m is equal 1, which makes the specific case of autoregressive random process.